collection example. So I am going to create one class, new class. The class name is collection example, and I want main that, so I'm creating one class inside my old object, old package. The class name is collection. So again, what is array? The array is a, what is array? Array is a collection of similar type of element into a single unit. Why we are going to create an array? Let us assume we want to create n number of variables. We want to create n number of variables inside my class. So I want to hold hundreds of variables. Then what we have to do earlier, we are going to create one array. That array is like that. Int, let's suppose int array arr is equal to new int and the size of the array. We are passing size of the array here. So then let's suppose I want to hold 10 sizes. Then what we have to do? This is the array which is created. What that meaning is? What that meaning is? Let us assume we want to create an array of I want to create an array which is having a 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that array name is ARR. 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 That ARR is pointing to this particular array. That ARR is pointing to this array which is holding and such elements. So if I want to hold that array, hold some values in that array, we are going to place some values 7, 6, 4, 2, 3, 1, and so how we are going to access these things? We are going to run that example. So to insert an array, I want to use one for int I is equal to 0 array dot length ARR. So how we are going to insert that thing? How we are going to insert that thing? I am going to use ARR of I is equal to SC dot next int. What is this XC dot next int? It is a scanner class through which we are inserting some value. SC is equal to new scanner system dot in. New sc dot in system dot. So this scanner is class is resides inside the util package. So I am importing that package as well. So what happened here? We are again one. We are going to type one message as well. Sysout, please enter. Please enter the element. Enter the element. Enter the element. And one by one, it is entering the element. So I am going to enter 10 elements. And how we are going to display that thing? Again, we are using for int array dot length, and I am again writing system dot out dot print. And I am going to print ARR of I. I'm going to execute that thing. Check it out what happened. Run as Java application. Enter the element. The element is, let's suppose, 12, 12, 22, 33, 44, 55, 66, 44, 5, 4. And check it out what happened here. One by one, the values are entered by me, by the first for loop, and the output of that array is corresponding. But what is the problem here? The problem is here only that this array is having a limited size. Whatever the size we are creating at the time of initial, then the array size is fixed. If I want to insert something beyond that array, what happened here? ARR of, let's suppose I want to insert inside 11 is equal to 44. Then what happened? There is no error such type. Compile time error is not there. But if I'm going to execute that thing, then what happened over here? Then there is an exception arise. What kind of exception is there? Array index out of bounds. So this is the one limitation of that particular array, the array having a fixed size. The another problem is there. If I want to insert a string type value inside this array, it is not possible. Only the integer type value which is declared earlier is only inserted. Is it clear? So what happened here? So that's why the collections comes into the picture. The collections are generic. First of all, the collections are generic. In what is the limitations of the array? The array are fixed in size. Once created, the size never be changed. The second limitation is array can hold only homogeneous data. Homogeneous data means same type of objects only. And they are not having any ready-made utility methods such available. Let's suppose I want to sort my array. I want to sort this array, then what happens? The array we have to create one sorting method explicitly by the programmer. Then that array is sorted, or use some predefined function which is available in some other classes. That's why the collection comes into the picture. What is the collection? So now we are again switching on to our slide. The slide name is. So what are the collection? If we want to represent a group of individual objects into a single unit, then we can use collection. If we want to represent group of individual objects into a single unit, that is called collection. Collection is a kind of container. Collection is a kind of container which can be. Collection is a kind of container which can be a box. You can imagine like a box. You can imagine such as a box. And we are going to create one array over there. So how kind of collection it is? You are going to create one box over here. Let us assume we have a box of collection like that. The collection name is C, and I want to insert one by one inside that. So I can add something in that box. We can add multiple values in that, and the feasibility is different. The fashion we have to create. Earlier, what we are doing, if we want to hold some value, let's say we want to hold some value in stack fashion, that is last in first out, we have to create a stack of that particular, whatever we want to store. We have to create such kind of classes. But in collection, what we are going to do, there are predefined classes available over there. What we are going to do, we are going to learn about how to use that particular classes in our coding. Let's just say that there is a bucket in my bathroom. We never know how that bucket is created, but we know about how to use that particular bucket. So what is the advantage of collection? A collection are auto scalable in nature. Whatever the limitation in the array, that array is fixed in size, but the collection are not. Collection are growable in nature according to our need. If we want to add something in that, it is created, it is inserted, it is scalable in nature, and the size of increase at runtime. It holds homogeneous as well as heterogeneous objects. We can hold a similar type of value inside that collection, and we can hold a different type of values in that collection. That will be explained further in the example. Every collection class internally implemented with the support of some underlying data structure. There may be, let's suppose we are going to create a stack. What you are using? You are using some linked list over there, or you can use some array and you can follow some phenomena of that particular stack. There is only one limitation of that particular collection. The collections are not work on primitive values. It can work only on objects. Now, moving further, we are going to discuss something else. So there are key interfaces are available in our collection classes. There is a one class called collection. Set interface is there, list is there, queue is there, dequeue is there, map is there, list iterator is there, sorted set is there, sorted map is there. Every collection has its own functionality. Every collection has its own functionality. They work in different scenarios and different situations. Moving further, we are going to check out the hierarchy of that class. The super parent class, super parent interface is there, that is called iterable. And the child is there is a collection interface. Collection interface extended by three interfaces. Those are called list, queue, and set. These list, queue, and set having a different functionalities. So anybody is, if anybody is asking what is collection, then collection is a container which is going to hold a particular object. Collection is a super interface which is having most common methods available in that collection interface. Collection interface not directly implemented by any other class. It is extended by some interfaces. That interface names are list, that interface are list, that interface are list, and that interface is called list, queue, and set. Moving further, the list is an interface, so that list is extended by these classes. List is directly extended by array list, linked list, vector, stack. In today's topic, we are going to discuss about these four classes, that is array list, linked list, vector, and stack. Moving further, we are going to check it out what is the collection interface and their methods. Collection is a root of the collection hierarchy. A collection represents a group of objects known as elements. As you see in this diagram, the collection is a super parent interface of all the collection classes So whatever the methods available in that collection is directly available, directly or indirectly available in all these classes or interfaces. Moving further, it declares the most common method. As I suggested, the collection is an interface which is having a most common method available in that. None of the classes implemented collection interface directly. See here in the earlier diagram, collection is not extended by any of the classes. It is extended by only interfaces, which is marked in red. So moving further again, none of the classes implementing the collection interface. Methods of collection interface are as follows. So there are lots of methods available in the abstract size. So we are going to discuss one by one. Number one, there is a one method. The method name is size. If you want to check out how many collections are over there, how many methods are there, you can simply, if you have a JDK installed in your collection, you are simply going to type java p java dot util. All the collection classes are available inside the util package. So there is a one collection interface you want to check. So I am writing java p space java.util.collection. If I'm going to enter, it is showing all the methods available inside collection interface. So these are the methods available in Java interface. That is size, empty, contains, iterator, object, do array, add, remove, contains, add all, remove all. We are going to check it out through our slide one by one. So what the first method is size is over there. It returns the number of elements available in my collection. In our example, we have a collection that may have multiple objects. In our collection here, we have 4 elements in that. So if I want to call the size method over my collection, then it returns 4. This collection is having 4 elements. What size method is going to do? Size method is returning the number of elements available in the collection. The another method is empty. What is empty is doing? Is empty is going to check whether the collection is empty or not. If the collection is empty, then it returns true value. And if the collection is having a single element in it, means the collection is not empty, it is returning a false. Moving further, we are going to discuss the next methods. Those are number 1, contains. Let us assume I want to check whether my collection is having such kind of interface or not. So what we have to do here, we are going to create one collection. We are going to create one collection over here. That collection name is, let us assume, I am having one collection. Inside that there is a 2, 3, 4, 5. In my collection, there is a 4 element. I want to call a contains method. So what we have to do, I have to write, let's say, c dot, I have to write c dot contains, and I want to check is my collection is containing 3 or not. Then what happened? My collection is containing 3 elements in that, so that the return value of this contains method is true. If I want to search 7, which is not present in my collection, so it returning false value. Moving further, check it out. We are discussing through the example these remaining methods, these remaining terminologies. The next method is iterator, that is also discussed further. ToArray. ToArray is a method. ToArray is a method which is converting all the. Let's suppose I have a collection which is having these 4 elements. If I am going to call C dot to array, then to array, then whatever the value containing by that particular object is converted into that integer type A. Means what? If I want to convert my collection to array, then what we have to do? We have to call ToArray method. So whatever the methods, whatever the values containing by that container is converted to that array. Next, moving further, there is a one method is called add. If I want to add something more in that then I have to call C dot. I am going to call C dot array, C dot add, and I want to add some element in my collection. Then I have to write 10. After execution of this add statement, the 10 value is added to my particular class. Let's say 10. And if the element is successfully added, this add method returns true. This add method returns true. That's why the return type of this add method is Boolean. As the description is saying, E element whose presence of the collection is to be ensured return true if the collection change as a result of call. Moving further, we are going to discuss about remove. If I want to remove something from my collection, I have to use this remove method. If it is removed, the element which is removed successfully, then it is returning true value. If the remove method is not successfully remove that particular element, or the element is not available in that collection, it is returning false. Contains all. This contains all method is, as the description is suggesting, C collection to be checked out the contain of the collection. Let us check out the example again. Let us have, I have another collection which is containing 2, 3. And the collection name is C1. And I want to check my C is containing all the collection or not. Then what we have to do? We have to write C dot contains all. And I want to check whether the C1 collection is totally present in the collection or not. Then we have to write like this. If C is containing all the elements containing by C1, then it returns true. If C is not containing one of the element, let's suppose I have a value that is having a 7 over here. In C1, there is a 3 element called 2, 3, 7. In C, there is a 5 element 2, 3, 4, 10, 5. But the C is not containing 7. So contains all return false. Next method is add all. Let us assume I want to add all the collection, let's say C1 into my C. Then what happened here? I have to use another method. That method name is add all. I have to write C dot add all. And I'm writing over here C1. Then what happened here? It is adding all the elements in C1 to C. Now the new elements available inside my collection is 2, 3, and 7. The numbers, the objects are duplicated. It is depending upon what interface, what class we are using. It is depending upon we are using list, or we are using linked list, or we are using set, or we are using key. It is depending on that is the duplicate elements are added to the collection or not. It is totally the different behavior of each interfaces. Now we come forward, we are going to discuss the next, remove all. Let us assume I want to remove all the collection, all the values available inside C1 to C. Then what happened? We have to write C dot remove all, and we have to pass C1. Means I want to remove whatever the values contains in C1 from C. Then what happened here? The 2 value is removed, 3 value is removed, and 7 is also removed from the C. Even though the values are duplicated, both the 2, both 3 and 7 is removed, and the collection is remains with only 4, 10 and 5. Switching to the next method, that method name is remove if. If you want to pass some condition over here, the value should be removed if the condition is true. We are discussing that further through the example. Retain all, again this method is, we are going to show you with the example of that particular collection class. The clear method is used if you want to remove all the variables from my collection, then we have to use clear. If I am writing C dot clear, all the methods, all the objects which is containing by that particular collection is removed. And the equal method is going to check if both the collection are equal. Moving further, we are going through the list interface. As we are showing in the hierarchy, the list interface is a child interface of the collection, but it is having some different functionality and is extending the capabilities of the collection interface. So, list interface is a child interface of the collection. There is a one phenomena we are discussing further. We are discussing that earlier, that the numbers are available inside the collection are duplicated or not. It is totally dependent upon the interfaces. What kind of classes we are using. So list is such kind of class which allows the duplicate values. It is also preserve the order. We can differentiate between the duplicate elements by the indexing. There is an indexing in list. If the 2 duplicates elements are available, there may be a chance this 2 value is indexed as like an array, maybe at 0 position, and this 2 at the 7th position. It is totally dependent upon the index. There are some methods available inside. There are some methods available inside the list interface. There are 3 methods available: get, set, and add. If you want to check again how we are going to check how many methods are available inside that, then again we have to write java p java.util.list, and you have to check it out. There are all the methods available in the collection interface is available here, but there are some new methodologies are available. Those are get, set, add. What these methods are going to do, we are going to discuss further. What is the get method is doing? If I'm going to pass some inside the what position, let's suppose array, there is an array, imagine the array. In that array, the element is on 2nd position. And I want to get that value, then we have to call get. In my example, I'm going to show you, if I want to get that, then I have to write c dot get. I am passing the position to. So whatever the element present on 2nd position is returned over here. That's why the return type of this is of collection type, generic type. Again, if I want to replace something inside my collection, then we have to use set method. Then the c dot set, we have to pass that value. Let's say I want to replace second position value through 10, 17. Then what happened? At the second position, whatever the value is there, that is replaced by 17. All these things we are going to discuss through our example. Next, add method. Add method is simply earlier, whatever the position you want to add that value, you are going to add that particular method. Now we are switching on to the remove. If you want to remove some element from their position, you have to pass the position in that and remove successfully. If you want to find out whatever the index of that particular object, then you have to use index of. If you want to find out what is there is a duplicity in that collection, then what we have to do, there may be a chance this 2 is at second position, this 2 is at 7th position, and you want that whatever the value object you are passing, what is the last index of that particular object, then we have to use last index of. Moving further, we are going to discuss about array list. This array list you are using, this is the class. Till now we are discussing about the interfaces, and you are very well know about interfaces. Objects never be created, so implementation of that list interface is directly used by this array list. Array list class has its own phenomena. The underlying data structure is scalable array. What is the underlying data structure? What is the underlying data structure? Let us assume I want to hold 10 value into my stack. Then you have to hold that value. You have to create a stack. Inside that stack, you have to create an array. I have to show you one example which is earlier created by me, that is called stack. Check out this stack class. This stack class is having one underlying data structure. We are using array over here to pass the values, to hold the values, whatever is pushed or popped. So we can say that this stack is having an underlying data structure array. Moving further, we are going to discuss next point. Array list implements list interface, as we discussed earlier. Interface, hence implicitly allow duplicate elements. Lists are allowing duplicate elements, and the insertion order is preserved. What is insertion order? We discussed. So it allows duplicate elements, means array list is allowing duplicate elements. As we discussed, the heterogeneous objects are allowed, except tree set and tree map. These two classes, tree set and tree map, not allow a heterogeneous objects. Null insertion is possible. All the collection object created to transfer through the network. Hence, all the collection classes implements serializable interface as well as clonable interface. Array list and vector class implements random access because they are using indexing and they want accessibility as an array. Hence, there is a random access interface, so that we can access an element randomly. Serializable and random access interface are the marker interface. So if you all have a doubt, you can post me on this chat. On the chat, I will reply you. This session is about 40 minutes. Again, I am sending you a link. You have to join again through the examples. Till then, take care.